My name is Stephen Hillier. I've got a long association with the Clay Minerals Group of the Mineralogical Society, and it's my great pleasure today to introduce Sabine Petit, who's based at the University of Poitiers in France. I think Sabine has been there for probably most of her career with some short sabbaticals across Europe. She's the director of research there, and also the recipient of several prestigious awards, the Gerhard Lagli Award. Recently, I think a Groupe Français des Agiles Senior Award, and also the George Brown Lecture Award, which I think was given in 2020, but because of conferences being delayed, Sabine is going to present the George Brown Lecture at the Mid-European Clay Conference coming up very soon. So Sabine, fantastic for you to agree to have a chat. And so let's kick off with the first question, and that was really just to get an idea of what started you off in clay mineralogy, who influenced the path you followed.
So thank you for the introduction. So in fact, I got into clay science when I was a child with my sisters and brother when we were playing outside and trying to make handmade gifts for parents with ingredients we were able to find. So this is more seriously. I discovered clay minerals when I was a student at Poitiers University when doing my master's study in geology. At this time, my teachers were, among the others, Dominique Ruigi, Daniel Beaufort, Alain Meunier, Alain de Caro, so famous people in the clay world, as you can see.
Yeah, it's a long list of famous people there in Poitiers. Yeah, it's
yes. Thus, I would say that I got into clay science naturally. And moreover, my supervisor for my master project was Alain de Caro. And this is him who so at this time he was a newly professor recruited at Poitiers University, and you know that he's famous in clay synthesis, and it's him who made me discover the clay mineral synthesis. So my master project was to synthesize kaolinite with structural iron. At this time, there were strong discussion, at least within the French clay group, about the status of iron linked to kaolinite, whether it was actually structural aluminum or not, and about what was its influence on its possible influence on kaolinite crystallinity. And in fact, during this master project, I was able to synthesize kaolinites with structural trivalent iron substituted to aluminum. And I remember I had to visit René Prost. At this time, he was in Versailles, famous scientist in Versailles, scaling infrared, to convince him that the band observed in the infrared spectra of the synthetic kaolinites was actually due to structural iron. Now, everybody knows that, but it was, I remember that. And I really began to have fun with my studies in geology, to tell the truth. It was not really the case before with this master work. And then I had the great opportunity to explore further the synthesis of substituted kaolinite topic.
So how much iron can you get into kaolinite? What's the is there a limit?
So the limit, I think there is no structural limit. Because due to my recent work with the George Brown Lecture, you will discover this, I think there is no steric effect, but the problem is probably more comes from the geochemical origin. I mean that the conditions are not met to synthesize that. And so I had the chance to continue to work on this topic during my PhD work, which was also supervised by Alain de Caro.
Mm-hmm. Yeah. And does Alain still come into the lab? Is he still?
Alain de Caro was emeritus for a while, but now he's no more emeritus, but he's still coming, visiting me from time to time.
Yeah.
And typically for the George Brown Lecture, I had to make a review work. So he was working with me on this topic.
Okay,
so
fantastic.
We met several times per year, and so this is great to have discussion.
Yeah. It's great to have these people that are constantly interested and never lose interest.
Sure.
Yeah. So, and I mean, the thing that always strikes me about clay science in France as well is just how active and how diverse and extensive it is. Why is that? Why do you think France has this, fantastic diversity of an activity in clay science?
The French clay group has a long history and has long been active, but it's not the only group with such past. Maybe the strength of the French clay group comes from the fact that in many places there are several people working with clays. I mean, more than one or two people.
For example, in the critical mass. Yeah.
In the past, Orléans, Versailles, Nancy, among the others, gathered a high number of people working with clay. And some groups have disappeared. For example, Orléans, Versailles, so it remains only isolated people, but others have been created. For example, at this time, you can find a strong team in Clermont-Ferrand working on double layer hydroxide. So in Poitiers too, we have a team of almost 15 permanent people working with clays it's the geology field, and including, and this is important, newly recruited young people.
Yeah.
And by the way, the name of our research team in Poitiers includes the word clays, argile in French. I think that for national clay groups, the existence of critical number of groups with a critical mass of people working with clay significantly helps to maintain and develop the activities of the group. For example, organizing meetings is, of course, obviously easier.
Yeah.
If you are,
how do you think other countries could learn from the kind of French system, if you like, then? Because I mean, clay science is just so strong in France. What if there was a key thing to pass over to other groups trying to develop clay science and keep it going?
The key thing is to attain this critical number of people in a place. You can also see, for example, the Slovak Academy of Science with Peter Komadel. And Jana Madejova, Juraj Budak. So they are still very active because they have the critical mass. I think this is a key point. And of course, that does not mean that the role of individuals is negligible. That, of course, not.
Yeah.
But if you have not some group of people with critical mass, I think it's far more difficult to, even for teaching for students, because if you are only one, you cannot develop lessons. You just some courses, some lessons, that's all. But if you are a strong group, that means you dedicate full program to clay science. So I think this is a key point.
Right.
And maybe, I don't know if the key point is to try to make group growing in size. Group, I mean, in a place. And so I'm relatively proud to have contributed to do that in Poitiers. Not, of course, not me alone, but to try to maintain this and to reinforce the clay group in Poitiers.
So. Yeah, no, absolutely. Because one of the places you think of straight away in France for clay science is always Poitiers. Yeah, it's definitely big group there. And so, I mean, you've also got a long record of kind of involvement with the various clay societies, IAPER, the CMS, a very current one, and Groupe Français des Argiles. What's been the best aspects of you of that kind of service? I mean, some people get involved in service and science, and some people stay on one side or the other. But for you, what have been the best aspects?
In fact, for me, it's more or less natural because So I will detail the aspect later, because just I should introduce that I invest myself in the French playgroup service very early in my career.
Yeah.
Because I got the secretary treasurer position of the French playgroup in the same time that I got my permanent position researcher at CNRS.
Mm-hmm.
So at this time there was no. So sorry, I'm not. That means that I'm not young, but there was no emails, and 2 meetings were organized yearly. So even if it was relatively time-consuming, it was really a fantastic chance for me. It allowed me to know the French clay community very well and to meet many famous clay scientists when I was a young researcher. It was crucial for me. In the same way, my involvement with the various clay societies allowed me, so it comes later, but naturally, because it was a logical following. So this involvement in the various clay society and AIPEA allowed me to meet many more clay scientists from all over the world. Much of them become also friends. And these friendly relationships makes things easier and enjoying under many aspects. For example, it definitely helps me to organize a Bridging Clays meeting in 2006. It was a joint meeting of the French Clay Group and of the CMS. Also, these friendly relationships allow me to find rapidly adequate partners for the Erasmus Mundus master programs, IMAX, dedicated to clay science. So it would not be possible if I do not know people, because they have to answer very fast, and they were very reactive, and so it was very efficient.
Yeah, I was going to ask about the Erasmus course, actually. That that has stopped now, is that right?
Yeah.
Unfortunately, yeah, but it was a fantastic initiative.
Yeah. So I have this topic too. I am very proud to have contributed to make it exist. Of course, I'm not the only. This was with all of team of people, many involved. Patricia Patrier, for example, who drive it, and it was it represented big work concerning all the administrative aspects of the European community. But yes,
very successful.
Yeah, it was very successful, and I'm very happy to see young people who followed this master program, who are now involved in the societies, in clay society, and you can see them in conference, in clay conference. So I'm very proud of that, and to have contributed to that. And unfortunately, yes, we have to stop because the program was no more supported by the European Committee. But now it's continuing more or less, so it's not the same status, but with some a program which is named EUR for European. Oh, sorry, I could not do just like that. I forget the acronym, but doesn't matter. So it's possible for foreign people to obtain grant and to continue to work. So the thematic is interface, material interface, because we have to work with another lab in Poitiers. But French students can apply to obtain grant to study clay minerals. So it is less dedicated, less focused on clay mineral than in the past program, but it's still
a big part.
Yeah. So
that's good to hear. Yeah,
people have to know. Yes.
Yeah.
And also this friendly relationships with other clay scientists into the world facilitate also PhD exchange, for example, PhD student exchange. For example, I welcome students from PhD students from my partners, and they welcome my PhD students. So to perform some specific studies, and you can do that with confidence. So this is very convenient. And also, it gave me the opportunity to have PhD students in the co-supervision. For example, I had PhD in co-supervision with Javier Huertas in Spain, Ricardo Scalenghe in Italy, Angelica Dovan-Ficarino in Brazil, and more recently with Hongping Yi in China. So all these things, I think, would not have been possible, maybe partly possible, but not so efficiently, if I would not be so much involved in the societies. So,
so great for networking, basically. It's definitely something to pass on. I mean, you I mean, as well as service to societies as well, you have a huge publication list, and I think it's probably fair to say it's kind of divided into two topics. There's the synthesis and the infrared. So one question I wanted to ask is, out of all the research you've done, what's been the most satisfying topic or problem that you've worked on, and why is that? What's made it that?
Mm-hmm. So in fact, yes, you're right. There's this two main aspects, play synthesis and FTIR. But these two main aspects are very imbricated. Mm-hmm. I mean, you need FTIR to characterize FTIR among the others, but I think it's a very appropriate technique to characterize those synthetic products.
Right. What have you actually made? Yeah.
It's very powerful because you can distinguish amorphous, and in the synthetic products you can see the substitution of follow crystal chemistry relatively easily, and you need sample series with as less as possible varying parameter to better infrared, so to better interpret infrared spectra, and synthesis allow to do that. So allow to obtain a sample series to better interpret infrared. So they are very imbricated, and it's difficult to separate these two topics. Mm-hmm. So I remember I was very excited with the pioneer work I made together with Jana Madejova from the Slovak Academy to interpret near infrared by using near infrared region, because near infrared, in fact, was used by clay scientists, but without interpretation. It was a
qualitative sort of.
Yeah. So, for example, for kaolinite substituted with various octahedral cations. So I spoke about iron, but we have also gallium and chromium substituted kaolinite. I was so excited to measure a position for the corresponding vibration band at the position I expected before measuring. So when I observed, when I measured the infrared spectra, I said, it's exactly where. So the band is at the position so I was so excited to that. So I appreciate, I enjoyed this work. Also, I was very excited to when I could measure in situ by infrared the ammonium exchange in smectite, because the ammonium changed the position of the band of the due to ammonium changed the position depending of its status in the clay. So when I could
is that how much it changes in relation to how much you have, or
you can exchange depending. So we prepare for example smectite, but you can do that with other minerals if it's variable charge. We prepare a series of ammonium exchange smectite, and we can follow, depending on the charge of the smectite, we can follow the exchange of the ammonium. So, and the bond position of the ammonium is not, if the ammonium is exchangeable, it's not the same position that it is not. So
when it's fixed versus exchangeable. Yes.
And so you can follow this exchangeability by infrared. So I was so excited because before doing these studies, I did not understand why there were several positions, and I could detect some mistake in paper. Some people who announced the same position, but with no spectra. In fact, they were wrong. So when making this experiment, so I was able to understand all I can read in literature. And it was very confusing before this work. So I was very enthusiastic with that.
I think you summed it up quite well there, actually, that moment of excitement that you get when you discover it. And I guess it's just discovery, isn't it? It's that prompts that.
Yeah. And I have to add that I was very enthusiastic too. And I had really a lot of fun with what I've just done for the George Brown lecture. To tell the truth, I was not expected to go so further in the result from a so simple approach. The approach, I have to say some word about that. So I made a review on the relation between the crystallographic B parameter of clay minerals and the octahedral composition of clay minerals, of course, in the light of the dimensional misfit between the tetrahedral and octahedral sheet. And it was so exciting that I spent far much time than I could expect. But I opened that.
So that will be that's included in your George Brown lectures. Yeah. Okay.
Yeah,
we're looking forward to reading that.
It will be the topic. It will be the topic of the George Brown lecture.
Yeah. Fantastic. So another question, I think quite a few of the sort of previous interviews have asked this as well, is what do you think has changed in clay science over the course of your career? What have been the big changes?
So I think the instrument to study clay minerals are far more powerful than when
instrumentation.
I began to work with clay minerals, and also software to process data. I remember that when I began my master project, I have to measure Morse-Bauer spectra, and I learned to decompose Morse-Bauer spectra with eyes. So fortunately, very soon after, softwares appear. So a variety of spectroscopic and instrumental techniques are more used to analyze clay. I'm very impressed by the improvement in sensitivity, selectivity, and accuracy. But among the others, the chemical and mineral composition of clay is still difficult to quantify.
Yeah, absolutely.
And, it's differences in clay mineral population, structural imperfection, variation with crystallinity and crystal chemistry, presence of impurities are still problems that are specifically associated with the identification and quantitative analysis of clays.
Mm-hmm.
And I think it still remains much work to be done to solve the problem.
Right. Yeah, no, absolutely. Yeah. So things have changed, instrumentation, other things like that. What do you think the most important emerging new areas are for clay science? Where do you think, if you had to look into the future, where's it going to go?
So in my opinion, maybe amongst the other, hydrogen storage, I think is an emerging topic and for clay science.
Yeah. And how is that? What is the?
So I not in only one way. I think it can be as a barrier or reservoir. I don't know, but I think there is a topic to develop in this point of view.
Okay.
Also in the materials field,
right?
It deserves to be explored, continue to be explored. I think about hierarchical materials, tissue engineering materials, biosensor, drug carrier, biomedical composites. All these fields are already explored, but I think that
they're growing and will continue to dominate. Yeah. No, that's interesting. Given these kind of new areas and things that are emerging, if somebody came along to you and said, right, here's a big pot of money, as much as you need, here's all the time. We get rid of all your other responsibilities, and you can work on one topic in clay science. What would that be?
I would love to study further the smectite crystal growth.
Crystal growth. Okay. Yeah.
Yeah, because I think I'm still not completely satisfied with different hypotheses you can find in literature concerning their small size. Oh, yeah.
Why they're small, or
yeah, why they are small, and why they can you cannot see them growing so much. I mean, in the especially in the plane of the layers,
right?
And this will be more or less the continuity of the work that was done for the George Brown lecture. Yeah, for me. So I would love to continue to do that.
Okay, and would you need expensive equipment for that, or resources, people, experimental, or just time? What would be the key? What would be the resources to investigate something like that?
Yeah, not really much money, but time, so sure, and also people. So money to pay.
So good people and plenty of time.
To have PhD students, so money for.
Yeah. And what exactly of that aspect is it about sort of smectite growth? Is it I mean, tell me something about what you know already about that topic that makes you think that's the, is it to do with nucleation?
I think
I think it's a fascinating area, clay mineral growth. Like you say, we know very little about it.
Yeah, so nucleation is not a problem, of course.
Right.
The problem is what is the process later? I mean, with time, what happens?
Okay.
What happens with time, or if you increase temperature? So if you increase temperature, but still in the limit of the don't change to transforming in talc or something like that, but still low temperature by increasing temperature. So I mean, the key factor is time. Key factor,
right?
To see what happened with time, and yes, I have, and smectite are flexuous, as you know, and so maybe there is a link, and I think I got some ideas with this George Brown lecture work, because I worked with all the families of clay minerals, including hydroxide, and by comparison, smectite are special one, but each family is special. So I got some idea about the reason why. So it's too early to say something more, but I would like to. Yes.
Yeah, that's good. It's interesting as well that like a review, the review that you've done there has immediately pointed you in a direction, thinking, we need to know more about this. I think that's an interesting aspect of doing a review, actually. And very much look forward to seeing the George Brown lecture. The other kind of question that comes out of that a little bit, actually, you synthesize clays in the laboratory where you don't have much time. Do you think they take a long time in nature, or do you think nature actually makes them very quickly and in an instant almost? And
I think that so you can to have nucleation, I think it's very fast, and depending on, it's interesting too. For example, if you can find kaolinite and smectite at surface, so in nature, so that means that they crystallize under surface condition. You can synthesize relatively easy smectite under surface condition. I mean at low temperature, lower than 100 degrees. Depending on the type of smectite, for typically iron-rich smectite or trioxidal smectite, it's possible to synthesize them at low temperature. But kaolinite, not possible easy. No, not possible. I mean, without a specific acidic condition, and still for kaolinite, some people maybe claim that you can observe some particle with transmission electron microscopy. crystallize at low temperature, but you cannot obtain a high amount of carbonite under 150 degrees. So, so this is the different concerning smectite. Depending on their chemistry, you can synthesize them at low temperature. But in fact, in laboratory, from my own experience, if you use temperature lower than 250, I think you can assimilate to surface condition. Just you gain time.
Right.
You get time. But if you increase the temperature higher than, for example, from 300 degrees, so that means that you are in under conditions. So you can obtain smectite or kaolinite, but it's no more. It's difficult to compare with natural conditions.
Right. Yeah.
Or of course, if it is hydrothermal kaolinite or hydrothermal smectite for such type of smectite, for specific type of smectite, of course you can compare, but not for example, you cannot obtain iron-rich smectite at 300 degrees. Yeah. So it depends of several parameters. Yeah.
And I guess lots of things still to learn then about clay mineral synthesis.
Yeah. Huge work to do.
Yeah, which is great. Yeah. And changing kind of questions now a little bit away from the kind of science, well, still staying on the science really, but any kind of important lessons over your career that you would pass on to, to students or early career researchers, if you had, a bit of advice to give them, what would that be?
So I will answer shortly. So I would just say that clay minerals are fascinating materials that deserve to be studied, and many things are still to be discovered. And sure, if you are curious and a little stubborn too, you will have a lot of fun. Clay mineral studies are typically interdisciplinary. There are so many fields of application, from environmental to material, dealing with geology, chemistry, physics, geochemistry, and so on, that one can find his own way, his own angle to attack, to explore them. And okay, I will also add that there are not negative results. From the results that appear negative, you can sometimes better understand things. So yes, do not hesitate to work with clay minerals.
Yeah, good advice. Yeah, just all your results are important, whether they don't come out the way you think or not. And finally, then I think we're possibly getting close on the time there. What do you do to relax? We spoke in Istanbul and at the ICC conference, and I remember you mentioned the cycling there. Yeah. And in fact, the other day, just yesterday, was it yesterday? No, Sunday. The tour of Britain came past my house in Scotland. So we have a tour of Britain, and I know you have become a cyclist, isn't it? And so is that the main thing you do to relax?
No, it's not the main thing. I like to spend time with my family and my animals, dogs, horses, and horses, I try to be, horses. I love horses, and I am also riding. Right. And I try to be outside as much as I can. In recent years, I discovered cycling very recently.
Yeah.
In 2008, in July 2018, and I enjoyed from this time to make cycling tours. So I was not a cyclist before, and for example, last year, together with a friend, we performed the Tour de France cycling. With you in Istanbul. And so we did the same cycling tour as the official one. And we spent the same number of days than the professional cyclists, but of course, we stayed in the saddle twice as long as they did. But it was, it has been an amazing
those must have been very long days then, because I know the Tour of Britain stage that came past my house just on Sunday was a long cycle, a long time. Yeah. Yeah, that's great. Yeah. No, I didn't realize you had all these animals as well. That's that's interesting. It's so I think we're probably more or less out of time, actually. I better wind up, but just to say thank you very much, Sabine, for agreeing to give us your thoughts on your clay science, what you've been doing and where it's going, and good luck with your George Brown lecture, which is coming up in a few days' time. MECC, I look forward to that, and it's been a real pleasure speaking to you. So à bientôt, j'espère. And
Merci. So
yeah,
thank you for giving me this opportunity for this
yeah,
interview.
you're very welcome. It's been fantastic speaking to you. Okay, take care.